Hello, my exceptional pre-calculus class. We are ready for another online adventure. Today, we will use double angle formulas to find exact values. This is in Chapter 7, Section 3 of our ebook. The double angle formulas are a special case of our sum formulas. Remember, we had the sign of alpha plus beta. Well, here alpha and beta are the same this time. In our book, in our ebook on page 585, we have the double angle formulas. The sine of 2 theta is equal to 2 times the sine of theta times the cosine of theta. The cosine of 2 theta is cosine squared of theta minus sine squared of theta, or 1 minus 2 times the sine squared of theta, or 2 cosine squared of theta minus 1. The tan of 2 theta is 2 tan theta divided by 1 minus tan squared theta. Here is an example of how we use our tangent sum formula and our double angle tans. You see the alpha and the beta are the same. And we use this formula. So this becomes tan of alpha plus tan of alpha, which is 2 tan of alpha, all over 1 times tan of alpha times tan of alpha is 1 minus tan squared of alpha. See, that's how we're using the sum for tangent to derive our double angle formula for tangent. Let's review just a little bit about our XY plane. In our first quadrant, remember both the X and the Y are positive. In the second quadrant, the X is negative and the Y is positive. In the third quadrant, both the X and the Y are negative. In the fourth quadrant, the X is positive and the Y is negative. Also, we need to review another way of looking at our right triangle. Focus in on theta. This side is the opposite side, which we're going to call Y. This side is the adjacent side we're calling X. And this side is the hypotenuse. So we know that the sine is Y divided by R. Cosine is X divided by R. Tangent is Y divided by R. And remember that cosecant is reciprocal of the sine, and secant is reciprocal of cosine, and cotangent is reciprocal of tangent. And according to our Pythagorean theorem, x squared plus y squared is equal to r squared. Also, we need to go back and review that in quadrant 1, all of the trig functions are positive. In quadrant 2, only sine and its reciprocal are positive. In quadrant 3, only tangent and its cotangent are positive. In quadrant 4, only cosine and its reciprocal secant are positive. Remember, if these are the only 2 trig functions in the second quadrant that are positive, then the other 4 are negative. And this corresponds to what? A smart trig class. All are positive in the first quadrant. Sine and its reciprocal are positive in the second. Tangent and its reciprocal cotangent are positive in the third. And cosine and its reciprocal secant, again, are positive in the fourth quadrant. A smart trig class. We're going to look at a problem that where we are given that the sine of theta, if the sine of theta is 5 over 13 and theta lies in quadrant 2, find the exact value of each of the following: the sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta. So that is our problem. So we're going to start off with what's given. And what's given is the sine of theta is 5 over 13. So this is like y over r. This implies that y is equal to 5 and r is equal to 13. We have to find the x. Since theta is in quadrant 2, the x is negative. We use our Pythagorean theorem. X squared plus y squared equals r squared. The y is 5, the r is 13. So we have x squared is equal to 25. X squared is plus 25, rather, is equal to 169. 169 minus 25 is 144. We take the square root of something that is square, we get plus or minus, but x is negative. because we are in quadrant 2. So x is negative. We're in quadrant 2. So now that we have the value of x, which is negative 12, the value of y, which is 5, the value of r, which is 13, then the sine of theta is given to be 5 over 13, and theta is in quadrant 2. Then the cosine of the theta will be the x over r, which is negative 12 over 13, and the tan of theta is y over x, which will be 5 over negative 12. So now we're getting ready to substitute into our double angle formulas. So here we have sine of 2 theta. Sine of 2 theta equals 2 times sine of theta times cosine of theta. Well, we just found, well, we were given that the sine of theta is what, 5 over 13. We found the cosine of theta to be negative 12 over 13. We multiply the three numerators, like 2 times 5 times negative 12 gives us negative 120. 13 times 13 is 169. So the sine of 2 theta is equal to negative 120 over 169. The cosine of 2 theta had three equations that we could use, but I chose to use this one. Cosine squared of theta minus sine squared of theta. Well, cosine squared of theta is negative 12 over 13 squared minus 5 over 13 squared, which gives us 144 over 169 minus 25 over 169. 144 minus 25, 119 over 169. So the double angle cosine of 2 theta equals 119 over 169. The third one that we're going to look at is the tan of 2 theta, and that is equal to 2 times the tan of theta over 1 minus the tan squared of theta. Well, we found the tan of theta to be a negative 5 over 12, so it's 2 times a negative 5 over 12 over 1 minus negative 5 over 12 squared. So 2 times negative 5 is negative 10 over 12. Negative 5 squared is 25. 12 squared, 144. So it's 1 minus 25 over 144. You have a denominator of 12 here. You have a denominator of 144 here. So the least common denominator will be 144. I multiply all three terms by 144. Negative 10 over 12 times 144. 1 times 144. Negative 25 over 144 times 144. 12 going to 12 once. 12 going to 144. 12 times negative 10 is a negative 120. 1 times 144 is 144. Here, 144 going to 144 once, so we're left with minus 25. And here we have the tan of theta equals a negative 120 over 119. So we have found that the tan of 2 theta is a negative 120 over 119. We found that the cosine of 2 theta is 119 over 169. And we found that the sine of 2 theta is a negative 120 over 169. And remember, when you're finding the double angle for cosine of 2 theta, you can use either one of these formulas to get that answer. And also remember that tan of 2 theta is the same thing as sine of 2 theta divided by cosine of 2 theta. There's different ways to look at those double angle formulas. And remember, as you are viewing this video, remember to stop, rewind, review. Stop, rewind, review. And my love goes out to you.